So we will be doing a lot of the financial math to finish up. All right, and so let's see. To start with this example, we're looking at what we call the continuous compounding formula. And what that means is you're doing interest continuously at every point in time. Well, does that sound possible? Yeah, it's possible with this mathematical formula. What you've learned before is we've kind of worked with the compound interest formula. Let me ask you a couple of questions, just make sure we kind of got this down here. Like if I said compound monthly, in this compound interest formula, M would be 12, okay? How about if I say quarterly? What does that mean? 4 times a year. What if I say semi-annually? What does that mean? 2 times, every 6 months, twice a year. So what we're doing with continuous is every point in time. So anytime that you're asked to do something with continuous compounding, totally different formula. You want to put this in. So if you wonder why I got my shampoo bottle, is because that's just what I think of. It's PERT, P-R-T, so it helps me remember that formula. All right. So what we're going to do is we're going to use this formula to solve this problem. So what we want to do to start out with this is, let's go ahead and just write down the PERT formula. That's A equals P-E to the RT. And of course, we learned what E was last time. You remember that E is about 2.71 approximately. It's an irrational number like pi. Okay, well, what you have in this is basically you're given the time is 5 years, and then you're given that the interest rate is 4.8% compounded continuously, and then you're depositing, so whatever you put in is called the principal, so that goes in like that. All right, and this problem is setting up and calculating on your calculator. So what you want to write down is we would have A equals 10,000. You want to plug in the 10,000 for P, leave E alone, and then the rate. What do you need to do at the interest rate always? Got to do something with that decimal. What do? Back 2. Okay, you got to change that back 2. If you don't do that, you're going to get a ridiculous answer. So move that back 2 to get 0.048. Okay, all right, and then the time is just 5 like this. Now the rest of this you're going to do on your calculator. Okay, I don't expect you to do in this modern world any other way. So if you got your calculator, get your calculator out, because you do want to make sure that you know where everything is on your calculator if this is new to you then. Okay, so let's see. Let me get everything cleared out of here. Come on. Okay, I think I'm good. Okay, so what you're going to do is you put in the 10,000, okay, and then E, if you notice your first column, you have an ln key. We'll learn about logarithms today. You would go second ln. That gets the E to pop up. Some of you are going to see E like a caret and then a parenthesis. A lot of you just see that superscript. So what you need to put in is just 0.048. and then multiply by 5. Let the calculator do everything for you. So just put it in one step, and then we'll round this off. Since we're talking about money, we just round this off to like 2 decimals. So we would have A is about $12,712.49. That's the answer to the problem. So that's real straightforward. Once you learn how to use that formula, then you want to use your calculator to get the rest of it. Is everybody okay with what I did there to start with? Okay. So anytime the problem asks for continuous compound, you use the A equals P equals E to the RT formula. Otherwise, if it's quarterly, annually, semi-annually, you use the compound interest formula. So you got to be on top of what formula you do. Okay. All right. The next thing here says that you have an account that has $50,000 in it currently, and it says after 15 years, at 5.75, again, it's compounded continuously. It says how much was originally deposited. So I would start the same way. Just write down the formula. The formula will lead you through how to do the problem. Okay, now let me ask you this question. This is the most important part of this problem. That 50,000, is that 50,000 P or is it A? It's A. How do you know? Well, because it asks how much was originally deposited. The question is to find P. Whatever you deposit originally is P. So what you're going to have in this problem is A is 50,000. That's not the principal. Everything else, of course, the time is 15. The interest rate is 5.75%. So you're going to plug in like this. So A is going to be 50,000. So you want to plug that in like that. You want to leave P alone because that's what you got to find. So we're going to have to do a little equation on this. E, again, change your decimal back, move your decimal back 2. So that will be 0.0575, then multiply by 15 like this. Now what you want to do on this, since you got great calculators, you want to do this in one step. So really all you got to do is you want to get P by itself. And this whole thing right here, this whole thing here is just a number. So you can divide both sides of this equation by this number to solve for P. Okay, you can wait till later to even put that in, or you could put it in before. So what I'm going to do is just divide both sides of this equation by that quantity like that. Okay, and then you can go directly to your calculator and do it in one step. Okay, so I'm going to put in just 50,000. And then divide by, and then just do, again, your second ln to get your E to come out, and then 0.0575 times 15. All right, and your calculator, as long as you know how to put stuff in, should do exactly what it's supposed to do. Get away, go away, McAfee. Okay, so we got that, and then that would end up giving us what the principal is. In this case, that would be $21,105.27. Okay, does that make sense to you guys that the answer is less than 50,000? It better be, okay, because what you're doing is that's how much you put in, but after 15 years, which is a long time, that amount will grow to 50,000. Okay, so you get a lot of interest. How would you find out how much interest? If you wanted to find the interest earned, all you would do to find the interest earned is you would just take $50,000 minus the $21,105.27. That would tell you how much of that money in your account came from interest. Okay, does that make sense to everybody? Yes or no? Tell me. Yep. Okay, all right. So if you got the formulas, most of these problems with the formulas, if you know what everything means in the formula and know how to use your calculator, it's not too hard to do. Okay. All right, so go to the next page. I'm going to let you go ahead and work on these for a few minutes and see how you do. Same thing I just did. You want to write down the formula, which is the PERT formula. I always think of it. Okay, A equals PE to the RT. Get all I need to see on your paper, set it up, go to your calculator. Okay, that's it. And I think I've kind of given you one of each. Then we'll look at one last thing here. Okay, and the reason you're getting such a big amount of money on number one is because it's 25 years. The longer out that term goes, the more your interest is going to grow. So this one really you just needed to do 75,000 times e to the 0.0395 multiplied by 25. Okay, just put it in one step on your calculator. And what I got, let's see, I got 201,338. Now I got like a 0.6092, so that means that 60's got to go up to 61. Okay, so what I ended up getting was this answer. That's what you should have got, $201,338.61. Is everybody okay with what you did there? Okay, and everybody knows where their E key is and everything. Okay, that's the key. All right. Okay, what'd you guys get on the second one? I only saw that on a few papers. You got a question? Yeah, where's the E key? Okay, the E key is right in the first column. Okay, so you see the LN key. You should see in like another color E to the X, so you got to go second, then do that. And then it'll just have an E, and then it'll have that exponent come out like that. Okay, so that's how I put that in. What'd you get on the second one? 6,700 or something? Yeah, go ahead. I've been using the E on the divided side. Oh, you can. Yeah, it doesn't make any difference. You can go E and then raise to if you want to. The benefit of doing this is it just automatically comes up as an exponent, but it doesn't really make any difference. Okay. All right, the next one goes like this. You should set it up as, again, you have A equals PE to the RT, but the $1 million is what you're shooting for. That's your goal. So you'd have 1 million there equals the principal. That's what you're trying to find. Then it would be E to the 0.125 multiplied by 40. And you got to solve an equation. So if you're going to isolate and get the P by itself, then you got to divide both sides of this equation by this quantity. And I would just wait till the end to just do your calculator in one step. And then if you do that, then you should be okay. So what I got when I put this in my calculator, 1 million divided by E to the 0.125 times 40, I don't remember what, yeah, here we go. This is what I got. The principal was $6,737, and then I got 94699, so that just needs to go up to 95 cents. So I got $6,737.95. Is that working okay? Is that what we're getting? Okay. All right, as long as you put everything in correctly, you shouldn't have any trouble with your calculator. All right. Okay, so that's kind of the two varieties of that we're going to look at. Anybody have a question about anything there on that?
Put the 0 for the 1.1.
For the what?
The 0. You don't have to, right?
For what? The percentage?
They're for all that.
No, you're talking about maybe the port where I did 0.125. You can do the 0, but it doesn't make any difference. Is that what you're talking about?
Yeah.
That doesn't make any difference.
Okay.
So that's up to you. You can leave that off. The calculator knows what you're talking about. Okay, let's see. The last thing I want to do is go down and do some exponential equations. Purpose of this is we're going to do this in the next section in logarithms. So it's just an activity to prepare you for something. Okay, so here's kind of the basic idea that I want to show you here is if you have an equation and it says a to the x equals b to the y, the idea, and to me this is logical, it's probably going to be logical to you. If a and b are the same, let's say that a and b are the same. Like if you had 2 to the x equals 2 to the y. Does it make sense to you guys that if the 2's are the same, that x and y have to be the same also? Is that logical? Okay, let me show you this. What if you had 2 to the third equals 2 to the question mark? What it has to be the question mark? 3. Okay, the idea is if those bases, the bases are the numbers below that you're raising to a power. If they're the same, the exponents have to be the same. All right, so actually solving these equations is just basically a direct application of this. So if you look at this problem, the bases are the same. Those are the numbers that are being raised to a power. So that means what you do to solve the problem is you just set the exponents equal to each other. So that's what you want to write on your paper is, since the bases are the same, if you can solve that equation, then you got it. Okay, now we're not going to do any problems where the bases are different on these things. It's just kind of a principle I want to find. Now we're going to go back to doing a little bit of equation solving. So if you get x by itself, what do you need to do? You need to subtract 5, okay, and then what you'd end up having from there is you would have 2x equals 6. In your head, what's the answer? 3, good, okay, you can divide by 2. So you got to go back to your equation solving skills that we learned before, okay? Now one thing I want to show you on this too is because anytime you're solving an equation, if you check it, you'll understand what in the world you did better anyway. So all I'm going to do is I'm just going to do 3 to the 2 times 3 plus 5 and see if that's 3 to the 11th. So I'm just replacing x with 3. Okay, well, in your head, what's 2 times 3 plus 5 anyway? That's 11, exactly. So you would have 3 to the 11th equals 3 to the 11th. Therefore, it's right. Okay, does that make sense? Okay, if the bases are the same, so are the exponents. That's the idea. Okay, the next one may challenge your background a little bit in algebra, but we have done this before. It's just been a long time. So I have 2 to the x squared minus x equals 2 to the 42. The idea is since the bases are the same, therefore so are the exponents. So what you want to write on your paper is x squared minus x equals 42. If you can solve that equation correctly, then you get the answer to the problem. This is a quadratic equation, so what you have to do is you have to move the 42 to the other side and you have to factor. Okay, we've done this before. It seems like it's been a while though since we've been doing probability and stuff lately. So you start that way, and then you got to factor, okay? So let's see if we remember how to factor. I hope so. Okay, so what are two numbers that multiply to give 42? There's lots of possibilities. There's 1 times 42, there's 2 times 21, 3 times 14, and there's 6 times 7. Which one's the best one? 6 and 7. How come? Yeah, because you're trying to get that middle term of -1, right? Okay, the rest of them are no good, so 6 and 7 is the one you want to go with. Okay, so we'd have x times x, we'd have 7 and 6, and how do you get 7 and 6 to add up to -1? One of them's got to be negative. Which one? The -7, right, okay? Because remember, -7 plus 6 is -1. Okay, anytime you factor anything, you want to make sure you FOIL it out and check it and make sure that you don't mess up on that. Okay, then what you do is you just take each factor, set it equal to 0. You're more than welcome to do this in your head. So what are the two answers to those last two equations? 7 and -6. Good. Okay, so the answers to that problem would just be 7 and -6. Okay, so I just write that. 7 and -6 are your answers. You could check the same way that I did the last problem if you wanted to. Okay. Okay, go ahead and go down and do the last two, and that'll finish up this section. These are straightforward. Notice the bases are the same. So you set the exponents equal to each other and solve the equation. So it's going to depend how well you can solve your basic equations. So this shouldn't take too long. Let's see. The first one, 2x minus 4 equals 10. What did you get as an answer? 7. Okay, should get 7, okay, because you can add 4 to both sides, or just move the 4. You get 2x equals 14. Divide both sides by 2, so you get x equals 7. Okay, that's it. All right. Second one's the same way. The 7s are the same, so you just write down the equation 3x minus 4 equals 2x plus 1 there. What did you get there? 5. Okay, if you did that right, you got 5. So what you can do is, the way I've been kind of showing you, is get the x's on the left side. So I'll leave the 3x. When I move the 2x, it becomes minus. I'll leave the 1. When I move the -4, it becomes plus 4. And you can do that in your head, so you get x equals 5. 3x minus 2x is x. Okay, is that okay with everybody? Okay, certainly not that difficult to do if you've got your equation solving down okay. All right, so I'm going to close this off.